Hey, so what we're going to do is continue finishing chapter 10. And so we left off on section 10.3. Might be a good idea just to kind of review 10.1, 10.2, and 10.3. But 10.4 is polar coordinates and polar graphs. Sometimes they do this in honors pre-calculus. Sometimes they don't get to it. I'm not sure if you guys have seen this before. We definitely don't do it in AB. So if you did see it, it's been a couple years. So instead of in terms of points in terms of X and Y, points are in terms of R comma theta. Okay. So R is the directed distance from the origin, we'll call it O, to some point P that we're going to call R comma theta. This is your length. That's your R. That's the directed distance. And this is your angle, theta. When R is negative, okay, when R is negative, when it's a negative number, you're going to go in the opposite direction. Opposite direction. I'm not writing everything out just because it's really hard to write with this mouse. Opposite direction of the pole. Okay, this is considered the pole right here, the origin. So if R is like -2 and your angle's like pi over 4, you would go pi over 4. If it's -2, you would go back this way. And we'll talk about that a little bit more. So let me just make sure I cover everything. I have my notes here. Okay, so x squared plus y squared equals r squared. That's the equation for a circle. Let's say we have this point r comma theta. We'll call it 2. That's your r. And theta, we'll call it pi over 4. Okay, so this is r comma theta. So obviously we know what tangent of theta is, y over x. Sine of theta is y over r, or in other words, opposite, which is y over hypotenuse, which is considered r right here. And cosine is adjacent, which is x. Okay, adjacent would be here over hypotenuse, which would be r. So the main thing that you need to know is that in polar, your y coordinate in a rectangular form is r equals sine theta, because if we solve this for y, we get r equals sine theta. You need to know that. And if we solve this for x here, you get r cosine theta. These are the two major ones that you need to know. Okay. There's other ways to represent this point 2 pi over 4, and that's what I was talking about with your r being negative. In polar, there's always 4 ways that we can write a point. So here's one way. Another way would be if we want to, let's say, go backwards. So if we go backwards, this is going to be -7 pi over 4. All right, and it still would be a directed distance of +2 because it's going in that positive direction from the pole. So one of the ways that we can represent this point is -7 pi over 4. That's a 7. And my r would be 2. That's if we're going this way, and the directed distance is 2. Now, you can go to this point here, directly across, and go backwards. To go backwards, that means our r would be -2. So let's think of the angle that way. So if we're going forwards, that angle is 5 pi over 4. And then you would go a directed distance of -2, because if we're here, we need to go backwards from that pole, which would be -2. And then, so we went forwards to get to this point. What if we went backwards to get to the point? That would be -3 pi over 4. And we would still be going a directed distance of -2 because we're going backwards from there. So there are 4 ways to represent this point right here. Here's one of them, and then here's the other 3. So we're going to practice example 1, taking it from polar and bringing it back to a rectangular conversion. Rectangular conversion would be x comma y. I'm just going to pick a different color. Okay, so we have our r is 2 and our theta is pi. So we could just simply use these equations right here, that x equals r cosine of theta. So that would mean x equals -2, because cosine of theta, or cosine of pi, sorry, is -1. And then y equals r, which is 2, sine of theta, which would be sine of pi. And sine of pi is 0, so y would be 0. So you would have the point -2, 0, -2, 0, which would be the same point as this point in polar. Okay, and let's think about it. So in polar, our theta is pi. So pi is over here, right? And our directed distance is 2. So we're going out 2. So it's this point right here. And our angle was pi. Well, that's the same point as -2, 0 in xy form or rectangular form. Okay. So for this next one over here, same thing. We're going to get x equals r, which is √3 cosine of pi over 6. Cosine of pi over 6 is √3 over 2. So x is, no, this is freezing on me. Okay, x equals 3 over 2. And then y equals r, which is √3 sine of pi over 6. And so sine of pi over 6 is 1/2. So that means my y is √3 over 2. So in rectangular form, we have the point 3/2 √3 over 2. Okay. All right, moving this down. So we want to go the other way now, rectangular to polar. Rectangular to polar. So just know that, x squared plus y squared equals r squared. That's your equation for a circle. So if we want to convert it to polar, we need the r, the directed distance from the pole, and theta. So if I plug in x and y, I get -1 squared plus 1 squared equals r squared. So r equals, that's going to be √2. Okay, so we already found our r, which is √2. And then there's a couple different ways that you can go ahead and find theta. You could actually use tangent and say tangent of theta equals y, which is 1, divided by x, which is -1. So where's tangent of theta equal to -1? That's going to be at 3 pi over 4. So 3 pi over 4. There you go. Well, you could also have used that x equals r cosine theta and just plugged in your x and your r. You could have used y equals r sine theta and same thing, plugged in your y and your r and solved for theta. So that's another way to do that problem. Okay. I just wanted to practice again. Let's write this r theta in 4 different ways. Here's one way. So let's think about it. Okay, you have 3 pi over 4, which is along this line over here, and you're going out root 2. Okay, so my directed distance in here is root 2. Okay, so what are the other ways that we could write this coordinate point? There's 4 total ways. We have 1. So we could go around. So we went counterclockwise. We could go clockwise, and that's backwards. And our directed distance would still be root 2, but what would the angle be? The angle would be, going backwards would be negative 5 pi over 4. Okay, so that would be going backwards, all right, and getting to that same point. You could go backwards and get along this line, okay, so that's just negative pi over 4, but we got to get back to this point, so we have to go opposite of our r, which would take us to negative root 2. And last but not least, we could go forwards all the way to the same spot, which would be 7 pi over 4. And then once again, our directed distance is opposite, so we would have to go back negative root 2. So there's your other 3 points to represent this point right here. All right, moving on. So we have our x is 0, our y is 2. So we could do, once again, x squared plus y squared equals r squared. So our r would be, it looks like 2. Okay, so we have that. So our r is 2. We need our theta now. Once again, there's different ways you could do this. Instead of using tangent, let's use cosine. So x, which is 0, equals r, which is 2, cosine of theta. All right, so I use the equation x equals r cosine of theta. So cosine of theta equals 0, and so where on the unit circle is cosine equal to 0? That would be at pi over 2. And there you go, there's a point there. Okay, this is really getting slow on me. Okay, so down here, we're going to convert polar equations to rectangular form. All right, so if we're just given that r equals 2, well, rectangular form means in terms of x and y. Well, we can say x squared plus y squared equals r squared. So we would get x squared plus y squared equals 4. That's in rectangular form. So we're done, and we just need to know that this is an equation for a circle. Okay. This next one here, theta equals pi over 3. So we need to get in terms of x and y. Well, we know that tangent of theta, so we'll put theta in there, tangent of pi over 3, is y divided by x. Well, tangent of pi over 3, 1/2 root 3 over 2. So when we do y divided by x, we're just going to get root 3. And so if we solve for y, we get y equals root 3 times x. There you go. This is just an equation for a line. And then the last one here, r equals secant theta. I mean, there's different ways you can do this, but make it easier for yourself. I'm already thinking that we know x equals r cosine of theta. So if I were to plug this r in, that's going to cancel. because when you have secant of theta, secant of theta times, okay, let's start this over. All right, when you have secant of theta times cosine of theta, right, this is 1 over cosine times cosine. That's just going to cancel to 1. Well, there you go. There's your rectangular form. This is also a line. It's just a vertical line. All right, so there's different ways that you can look at this. You're just kind of figuring out, seeing what works best and what might be the easiest. All right, moving on. Okay, now we're going to start graphing in polar form. And there's different types. So you see you have circles, limesons, I don't know if I say it right, roses and lemniscates. So there's different types, and it's good to kind of recognize the form, and so you have an idea of what it looks like. I'd like to also see you play around with your calculator so you get familiar with like changing your calculator from rectangular form to polar and plugging that in as well. That would be good practice, and you can do that on your own. So what I want you to know with circles is that you only need from 0 to pi to complete the circle. So if you go from 0 to 2 pi, you're going to go around the circle twice. I also want you to know when you have sine, it's easier to use the pi over 6 angles because it just works out with nicer numbers, because sine of pi over 6 is 1/2. And with cosine, it's easier to use the pi over 3 angles because cosine of pi over 3 is 1/2. Along with the quadrantals. When I say a quadrantal is 0, pi over 2, pi, 3 pi over 2, 2 pi. Okay? But you only need to go from 0 to pi to complete this circle. So since we're dealing with sine here, you want to start with 0, and sine, we're going to use the pi over 6 angle. So we do pi over 6, then 90 degrees, which is a quadrantal, so that's pi over 2. And then the next angle would be 5 pi over 6. And then to complete the circle would be pi. So when you plug these in, when you take these thetas and plug it in, you should get 0, 3/2, 3, 3/2, and 0. Okay, so starting with, I always start with the angle that would be at 0, that would be on this line, and their directed distance from the pole is 0. So you're starting at the origin or the pole. And then at pi over 6, okay, that's along this line, right? The angle pi over 6 just goes to about here. So along this line, and I sometimes will draw that like pi over 6 angle, that line. You're going out 3/2. So that's just 1.5. So you're on that line. There's your point. Then pi over 2 goes to this line here, and you're up at 3. At 5 pi over 6, that's this angle that takes you right to this line here. Right? 5 pi over 6 goes around right to here, and you're going out 3/2 again. And then you're back to pi, which is this angle, but you're at 0. So when we go to draw this, you know it's going to be a circle. This is going to be horrible. It's not too bad. There's your circle. And because it was in terms of sine means it sits more on the y-axis. So you kind of should have an idea of like, all right, where's this circle going to lie? Another thing I want to show you is if I asked you to take this and convert it to a rectangular equation, what you can do is you can multiply both sides by r. If you do that, you get r squared equals 3r sine theta. And then r sine theta that equals y. So it'd be 3 times y. And then we know r squared we can replace as x squared plus y squared. And this is equation for a circle, so I need to get it in that form. So I need to move the 3y to the other side, set it equal to 0. Okay, because I'm running out of room, I'm going to go up here. And then I'm going to complete the square for this part right here. So I have y squared minus 3y. Half of 3 is 3/2, square it is 9/4. So I'm adding 9/4. And what I do to the left-hand side, I'm going to also do to the right-hand side, meaning add 9/4. And here we get x squared plus, okay, now that I completed the square, I can factor this into y minus 3/2, quantity squared. So here is your circle equation in rectangular form, and this is saying it has a center of 0 because this is x minus 0 quantity squared. So 0 is your x, and the y would be 3/2 because that's what would make this parenthesis 0. So look, your center is 0, 3/2 right here, and then from there, your radius, this is r squared, would be 3/2. So there you go there. Okay. So prediction for the second one here, r equals 3 cosine theta. Well, since it's in terms of cosine, it's going to sit more on the x-axis. So sine sits more on the y-axis. This is going to sit more on the x-axis. And because we're dealing with cosine, we're going to use the pi over 3 angles. So we have 0, pi over 3, use the quadrantals, pi over 2, and then we're going to have 2 pi over 3, and then pi. Okay, remember 0 to pi completes a circle. Going 0 to 2 pi will go around twice. So when you plug these thetas in, you're going to get for your r 3, 3/2, 0, negative 3/2, 0. So let's graph that. So the angle 0, which is right along here, 3. There's your first point. Then at pi over 3, which is along this line, you're going out 3/2. That's right in the middle here. Then at pi over 2, which is this line here, you're at 0, so you're at the pole. At 2 pi over 3, that's along this line. You're going a directed distance of negative 3/2, so you're actually going backwards from the pole. And then at pi is along this line, you're back at 0. So let's get a different color. There's your circle. It's a horrible circle, but best I could do. And you can see it sits on the x-axis, okay? And you could get the equation for the circle in rectangular form the same way that we did here. You'd multiply both sides by r, and then your right-hand side would be 3r cosine, which you can write in terms of 3x, and go from there and complete this square. Excuse me. Okay. Limesons. So you actually need to go out to 2 pi to complete these. We're not going to do every single one to detail, but I do want to show you a couple. And this is the format r equals a plus or minus b sine theta. When it's in terms of sine theta, you should know that it lies more on the y-axis, and when it's in terms of cosine, it lies more on the x-axis. Now, if a and b are the same number, it's a cardioid, which means it looks like a heart. When a is greater than b, it's going to be slightly dented, so it doesn't go in as much as a heart, but it is slightly dented. And then when b is greater than a, you actually have a loop in the middle. All right, so with our first one here, cardioid. We know it's going to sit on the y-axis. We know it's going to be a heart. And since we're dealing with sine, we want to use the pi/6 angles. So I'm going to make a theta R chart here. Oh gosh, horrible straight line. Okay, so we're going to pick 0, pi/6, the quadrantals, so pi/2, 5 pi/6, and at this point we're only halfway done. Pi, because we need to go out to 2 pi. So the next pi/6 angle is 7 pi/6, then 3 pi/2. All right, then 11 pi/6, and last but not least 2 pi, and that'll complete the circle here. Okay. So when we plug in carefully 0, you got to take your time. First R is going to be 2, then 3, then 4, then 3, 2, 1, 0, 1, 2. All right, and let's see how we make out here. So an angle of 0 and a directed distance of 2. Here's where we start. An angle of pi/6, so that's along this line, and a directed distance of 3. An angle of pi/2, so we're along this line, and a directed distance of 4. 5 pi/6, so we're along this line, and a directed distance of 3. At pi, we're a directed distance of 2. At 7 pi/6, we're along this line. It's a directed distance of 1, right there. 3 pi/2, or the origin. 11 pi/6, we're out at 1. And then at 2 pi, we're back to 2 here. So when I go to draw this, remember, it's going to be heart-shaped, and it's upside down. There you go. There's your heart. Okay? And if you were to do the same thing, and then we're not going to sit here, and you could graph this on your calculator, that would be a good practice. But this one is going to sit more on the x-axis, because in terms of cosine, and you should use the pi/3 angles along with the quadrantals, and it ends up going up to 3 here, out to 6, down to -3, and there would be your cardioid for this one. Okay? The dented one here, like I said, you could sit here and list it all out, but it actually goes up to 1 here, okay? It's out to 2 on the sides, out to 3 along pi and a 0, and it looks something like this. So it's slightly dented. No, that was horrible combo. It almost looks like it wants to be a heart, but it's not indented enough in this spot. It's just ever so slightly dented. There we go. That's better. Okay? Like, I guess maybe it looks like an apple. I don't know. And then the loop here. So since it's in terms of sine, so see how this one is in terms of sine, it sits more on the y-axis. Same thing here. This will sit more on the y-axis. This actually has a loop. And it looks something like this. There we go. And you would get that I'm going from 0 to 2 pi using the pi over 6 and the quadrantals. And you can see where it starts, where the loop begins, and we're going to need that more when we go into finding area under polar curves. But you just recognize that this would have a loop, this would be slightly dented, this would be a heart, okay? Think about where it would sit, what axis. All right, last part, roses. So just some things about roses, just some notes. So when n is even, when n is an even number, okay, that would be this number right here. So this 2 is even. To get the number of petals, you would double n. So you would double for the number of petals. That's when n is even. When n is odd, okay, it would be the same, whatever that number is, it would be the same number of petals. Okay, so A is the petal length. So here our petal length is 3. And since this number here is even, we're going to have double that. We're going to have 4 petals. All right, and we're going to actually go through and do one of these at least. So theta comma r, you actually need from 0 to 2 pi to complete these. So if we start at 0, you get an r of 0. And here's where you got to be careful because you're doing 2 times theta. So putting in pi over 6 is not necessarily going to help us because then you'd be doing sine of pi over 3. And sine of pi over 3 is root 3 over 2. Like, we don't want weird numbers. So actually a good one to plug in would be pi over 4. Because when we plug in pi over 4, 2 times pi over 4 is pi over 2. And that's a nice, easy number to work with. So then we also want to do pi over 2. And then 3 pi over 4 would be nice because when you plug it in, it would be 3 pi over 2. Then pi. Okay, we want to stick with the quadrantals. And then 5 pi over 4. Let's see what happens here. So we get 0, 0, pi over 4, 3. Then we get 0. Then we get negative 3. I'm getting these numbers by taking our thetas and plugging it in. And then you'd have to know the unit circle and be able to calculate from there. 0, and the last one is 3. So I know we didn't go out to 2 pi, but maybe we can figure out a pattern here and see what's going on. So 0, 0. Then pi over 4, 3. So pi over 4 is along this line, right? This is the angle pi over 4. We're going out 3. There's your first petal because we know the length is 3. And then at pi over 2, we go back to 0. So there's your first petal. We know we need 4 of them. At 3 pi over 4, that's along this line, you're going back a directed distance of negative 3. So I'm going out here. And then at pi, I'm going back to 0. So we just completed that petal. All right, and then if you go to 5 pi over 4, 5 pi over 4 is down here. And you're completing this petal in the third quadrant and then the last one in the second quadrant. And there's your 4 petals with petal length of 3. Okay, and if we were to do the same thing for here, our petal length would be 4. The number n is odd here, so we're only going to have that number of petals, which would be 3, and this is going to sit on the x-axis. So it actually goes out to 3 here, first petal, and then there's going to be one down here, and then one out here. Oops, and this should have been out to 4. Okay, so let's pretend that's 4. Okay, petal length of 4. All right, so 3 petals here because the number's odd and the petal length is 4. All right, lemniscates, last one. Okay, A stands for the petal length. All right, and this is in the form of r squared equals a squared sine 2 theta, or r squared equals a squared cosine 2 theta. With this, okay, with the sine, it being sine, it lies between the axes, right? And the petal length here would be a, and when it's on cosine, it lies on the x-axis. And petal length would be a. Okay, well, that's supposed to be an a in there. So for this example, r squared equals 4 sine 2 theta. Our a is 2, okay, because this is a squared. So our petal length is 2, and so it's going to sit in between the axes. And here, our petal length would be root 3, and since it's cosine, it sits on the x-axis. So there you go. And we're going to stop there for day 1.